Hi YouTube, this is Mike, and this is part 2 in my series on craps math. All these videos are designed to not just help you understand how to play craps, but they also are going to go through the math of the games, showing you the expected value of the various bets in craps. So hopefully you'll have a better understanding of the game mathematically, and you will see why some bets are better than others, and hopefully you will learn something from these videos and make better bets in craps and lose less money when you play over the long run. So in part 1 I covered the pass bet and taking the odds. In part 2, this video, I'm going to be covering the don't pass and laying the odds. So let's start with a demonstration of the don't pass. First, a quick review of the pass bet. Here are the rules for that. If the come out roll is a 7 or 11, the pass bet is an instant winner. A 2, 3, or 12 is an instant loser. Otherwise, on a 4, 5, 6, 8, 9, or 10, that becomes what's known as the point. Then the object becomes to roll the point again before you roll a 7, and you will just keep rolling the dice until one of those two events happens. Now the don't pass bet is almost the opposite. The only exception to being exactly the opposite is that a total of 12 on a come out roll does not become a winner on the don't pass. It's only a push. If it were a winner, then the player would have a 1.41% advantage. And we can't have that now, can we? Because the casino always must have an advantage, or at least break even. So let's jump in with a demonstration here. It's a come out roll as evidenced by the fact that the puck is in the upper left corner in the off position. So let's make a $100 bet on the don't pass, and it's a come out roll. Here we go. Okay, I rolled a 5, so the point is a 5. So now I want to roll a total of 7 before a 5, and I'm just going to keep rolling until one of those things happens. And I get a 7 on the second roll, so I win. You can see my balance went up by $100 to $10,100. And the don't pass, if you win, it always pays even money, much like the pass bet. So let's make another bet. The point is a 3. That's an instant winner on the don't pass. So let's go again. The point is a 6. So again, after the come out roll, you always are rooting for a 7. And I rolled a 6 before a 7, so I lost. So let's go again. A 7 on a come out roll is a loser. 4, so now the object is to, well, it's again, if you roll any point, the object is always to roll a 7 after that and not to roll the point. So we're rolling for a 7 here, and there we got it. So hopefully you now understand the don't pass. So next I'm going to go on to explaining laying the odds. Next, let's demonstrate laying the odds. So you always start with a don't pass bet. And here we go, come out roll. And 11 is an instant loser on the don't pass. So let's try again. 3 is an instant winner, so let's go again. And 8. So so if the point is an 8, then if you lay the odds, much like the don't pass bet itself, you're going to win on a 7 and lose if the point is rolled. Laying the odds pays 5 to 6 on a point of 6 or 8. So if the odds allowed on the table are 3, 4, 5 times the pass bet, then, as they often are in Las Vegas, then laying the odds, you can always lay 6 times your don't pass bet. And that conveniently works out to a win of 3 times the don't pass bet on a 4 or 10, 4 times on a 5 or a 9, and 5 times on a 6 or an 8. In other words, you can bet as much as you need to win that 3, 4, 5 times the don't pass bet. And again, it always works out to 6 times the don't pass bet. So it's very simple, just always bet 6 times. as much. So there's 1, 2, 3, 4, 5, 6. So I have 600 laying the odds. And by the way, I'm playing all this on my craps demo game, which you can find on my site, wizardofodds.com. And where you actually put the bet is in this thin line between the pass and the don't pass. And if you play at an actual table, now I'm not sure if this is right. It's been a while since I actually played, but I believe you put the bet right next to the don't pass bet in that don't pass part of the table, and you heel it, meaning that you put part of the bet on the edge of the don't pass bet. But correct me if I'm wrong on that in the comments. All right, enough talk. Let's roll the dice, and we're rolling for a 7. 4, nothing happens. Another 4, nothing, and an 8. So I lost. So let's try again. 100 on the don't pass. 3 is an instant winner. And 8, another 8. So I'm going to bet again the full 600 on the don't pass, and that 600 is going to win 500 if I roll a 7 before an 8. So let's take note right now. My balance is 8,800 and an 8. So I lost again. So let's try again. 100 on the don't pass, a 9. So let's put up the full 600 here, and this 600 is going to win $400 if I roll a 7, which just happened. So again, my don't pass bet won $100. The $600 taking the odds won $400. So I won a total of $500. And you may recall that I mentioned how my balance was $8,800 the last bet. Well, it stayed there because I lost. And now it has gone up to $9,300, showing that gain of $500 that I just won. Again, 100 on the don't pass and 400 laying the odds. So let's do it one more time. Another 9, so I'm going to back it up with the full 600. 4, nothing happens. 8, nothing happens. And a 7. So I win another $500. And so I think that's a sufficient demonstration of the don't pass and laying the odds. So let's change gears here and do some math. Okay, YouTube, are you ready to do some math? I am. So I am going to build on the spreadsheet that I developed in part 1 of this video. And everything ultimately comes down to this combinations sheet. This shows the total of all the possible ways you could roll 2 dice and how often they occur. And I go over this more slowly in part 1 of the series, but you can see there's 36 possible ways to roll 2 dice, and this shows the number of combinations that result in any given total. So you can see in this graph here, the most likely outcome is a total of 7, and then the probabilities or the combinations go down from there as you get away from 7 on an inclined plane. So as a reminder, here is my sheet on taking the odds that I developed in part 1 of the series. So I'm going to copy and paste this over to a new sheet called laying the odds, just to save time. And I have to change some things. I'm going to change the pays and the combinations because they're different if you're laying the odds. Now, okay, where shall I start? Let's start on laying the odds after a point of a 4 or a 10. Now, as I explained before, when you lay the odds, you always win on a point on a total of 7. How many ways can you roll a total of 7? Well, let's go to our combinations sheet, and we see for a total of 7, there are 6 ways. And this is going to be true for any given point. You always win on a 7. So going back to a point of 4 or 10, let's say, for example, the point is a 4. how many ways can you lose with a total of 4? Well, again, let's go back to our combinations sheet, and we see that there are 3 ways to roll a 4. So we put that in there. So there's 9 ways you can win or lose. So the probability of winning is 6 divided by 9, or 2/3, and the probability of losing is 1/3. And that's one nice thing about laying the odds, is that you win more. But of course, you don't win as much when you do win. The odds bet will pay 1 to 2 or 0.5 if the point is a 4 or 10. And if you lose, obviously you lose the whole thing, as represented by a -1 for the win. And as before in part 1, the return column is the product of what any event pays times its probability. So you go through that for all the possible outcomes, and then you take the sum of that return column to get the overall value of that bet. In this case, it's +1/3 plus -1/3, resulting in 0. That 0 signifies that there is a 0 house advantage, there's 0 player advantage. It's a perfectly fair bet, and the expected value is 0. That means that you can expect to win nothing. And you can also expect to lose nothing. It's a perfectly fair bet, and you don't often get an opportunity to make a fair bet in the casino. So I think that you should seize the chance while you can, as long as you're gambling in the first place, which obviously you are, as evidenced by the fact that you're standing at a craps table. So let's go on to the 5 and the 9. I already showed that there's 6 ways to win. How many ways can you lose on a point of 5, for example? Well, let's go back to the combinations sheet, and we see that there are 4 ways you can roll a 5. So there's a 60% chance of winning, 40% chance of losing. The laying the odds pays 2 to 3 on a point of 5 or 9. And if you lose, you win. You lose the whole thing, or in other words, you win -1. So the return column here, take the sum of the return column, 40% minus 40% is 0. So again, perfectly fair bet, 0 house advantage. So finally, let's go on to the 6 and the 8 here. We know that there's 6 ways to win on the 7. How many ways can you roll a 6, for example? There are 5 ways. So 11 ways to win or lose. The probability of winning is 6 divided by 11, or about 54.55%, and the probability of losing is about 45.45%. A winning bet pays 5 to 6 odds after a point of 6 or 8, and it pays -1 on a loss. So again, you take the sum of the return column and you get 0. So in all 3 cases, the expected value is 0. Again, 0 house advantage, 0 player advantage. It's a perfectly fair bet. So next, let's go on to working on the don't pass, which is a little bit more mathematically involved. Finally, in this video, let's work out the odds of the don't pass bet. And right now we're looking at the sheet for the pass bet. And as developed in part 1 of this series. And cell D39 here is the bottom line. It shows an expected return of -1.41%. In other words, on the pass bet, you can expect to lose 1.41% of all the money you bet. So we mathematicians like to work off of a previously solved problem. So I'm just going to copy and paste all of this. Copy, and I'm going to paste it into a new sheet called Don't Pass. And so this is all the same, the number of combinations for each total and the probability of rolling any given total. But let's adjust this a little bit. First, let's just completely cross all that stuff out, and we just need to add one more possible event, And let's put it between the winning and losing outcomes. So let's insert a row here. And let's call this a come out push. Okay, so, and let's copy and paste these two formulas down. And let's get rid of all this because we need to completely redo the probabilities. Okay, we're ready to get started here. Wins on the don't pass always pay even money, and it doesn't matter how you win. A push always pays 0, and a loss you always lose your full bet, and it doesn't matter how or why. So what is the probability of winning on the come out roll on the don't pass? Well, as a reminder, that's going to happen if you roll a total of a 2 or a 3. What's the probability of rolling a 2 or a 3? Well, we can see it's 2.78% for a 2 and 5.56% for a 3. So we just take the sum of those two probabilities. And let's do the easy stuff first. What's the probability of a push on the come out roll? Well, as stated before, you push on the come out roll on a total of 12, and we can see right here that probability is 2.78%. And how about a come out loss? You're going to lose if the come out roll is a 7 or 11. So we take the sum of cell C16 here and C20. So there is a 22.22% chance of losing on the come out roll. Anything else is going to means that you rolled a point. So first let's look at the probability of winning, assuming that you rolled a 4 on the come out roll. So that probability is going to be the probability of rolling a 4 on the come out roll in the first place, which is 8.33%, times the probability of winning after that point is thrown. And as a reminder, you're going to win if you throw a total of 7 before you throw a total of 4. And we have already established that probability in the laying odds sheet. So here we show the probability of winning, laying the odds after a point of 4. We have shown the probability is 2/3 of rolling a 7 before rolling a 4. So we can just reference that cell. So the product of those two events is 5.56%. So how about winning after a point of 5? Well, the probability of rolling the 5 in the first place is 11.11%. So we reference that cell C14, and we multiply that by the probability of rolling a 7 before a 5 or a 9, which we have already shown to be 60%. And doing the same thing for a point of 6, there's a 13.89% chance of rolling a 6 on the come out roll. And we have established that the probability of rolling a 7 before another 6 is 54.55%. So we can reference that cell. And we have shown in the combinations sheet how the most frequent total is 7, and then it declines equally as you get away from a 7 on an inclined plane. So let's go back to the don't pass sheet. Thus, the probability of winning on a point of 8 is the same as a point of 6, because the probability of rolling an 8 is the same as rolling a total of 6. So I can just reference that cell there. And a 9 has the same probability as a 5, so I can reference that cell. And the probability of a 10 is the same as a 4, so I can reference that cell there. Because it's like mirror images of each other. Okay, let's move on here. How about losing after a point of 4? So, as shown before, the probability of rolling a 4 to begin with is 8.33%. So I take the product of that, and I go back to my laying odds sheet. the probability of losing after a point of 410 is 33%. So I can reference that cell there. So there's a 2.78% chance of establishing a point of 4 and then eventually losing. So let's do the same thing with a point of 5. There is an 11.11% chance of rolling that 5. And then, assuming that you do, there's a 60% chance of losing. I'm sorry, a 40% chance of losing. So there we go. Same thing with a 0.6 loss. We take the product of cell C15 here and cell D19 in the laying odds sheet. So there we go. And for the exact same reasons that I just explained, the 8, 9, and 10 are the odds are the mirror image of the 4, 5, and 6. The 9 is the same as the 5, and the 4 is the same as the 10. So you can see that the probability column adds up to 100%. If it didn't, then that would have indicated I made a mistake somewhere. And the return column, the sum of all these returns is negative 1.36%. So there you have it, a house advantage of 1.36% on the don't pass bet. So how does that compare to the pass bet? Well, let's go back to that sheet, and you can see the bottom line is 1.41%. So therefore, the odds are a little bit better on the don't pass bet by 0.05%. So it's only a hair better. If you must play completely by the math, then you should be making the don't pass bet rather than a pass bet. However, you're not going to get the wizard's finger wagging of shame if you bet the pass bet, because again, it's only a 0.05% difference, and I think most players find it more fun to bet on the pass side because that's what most other players do, and if you get that kind of contact high when the whole table is winning with you, then you, to be honest with you, you might have more fun on the pass side. But that's completely up to you. As long as you're betting one or the other and taking and laying the odds to take advantage of those bets that have zero house advantage, then craps is going to be an outstanding value. So yeah, that does it for the don't pass and laying the odds. And in part 3 of this video, I'm going to be going over betting on the numbers, whether you want to call that place bets, buy bets. That's what I'm going to be talking about in part 3. So I hope to see you over there. Thanks for making it to the end of this video. I hope you learned something. I hope this will help your craps game, and I will see you in another video. Thanks for watching. Bye.